Hey guys, it's Miss Wiesner, and this is going to be the first of several lessons that we're going to be doing that cover slope. And in this case, talking about slope of a line or the steepness of a line. And today we're going to look at the slope of a line on a graph, because there's several ways to look at slope, but we're going to actually look at graphs first. So slope is steepness, and there's, like I said, there's many ways to find this. The first way we're going to find it is by using what's called rise over run. But to review, in case you missed it, oh shoot, you mean I think I did all that? Okay, so when finding steepness of a line on a graph, you can find the distance between 2 points on the line. And as I mentioned before, we're going to use rise over run. Now, sometimes you get to choose which 2 points that you want to use. Sometimes there'll be 2 points marked on the graph for you to use. So either way, as long as you find 2 points on the line and do what I do, you should get the correct answer every time. It's just one of the many ways of finding it. Okay, so for number one is the first thing I do when I'm looking at finding slope of a line on a graph is I look to see, is this a positive slope? Because if it's a positive slope, then that means that my number, whatever I find, it might be a fraction, it might not be, but it needs to be positive. Okay, so I'll automatically look at this and I see that, okay, well, I should be ending up with a positive number. And I also look to see if there's already points on the line that I'm supposed to work with. And there are. I have this one and this one. So here's how rise over run works. Remember, it's that same notion of y over x. Y's like top dog there, so you got to do the change in y. So that's the same thing as rise. So I'm going to go here and I'm going to count the number of times. 1, 2, 3, 4. So I went up 4, and then I'm going to the right. How many times? Went to the right twice. So if this can be simplified, then you need to simplify it. Can 4 halves be simplified? Yes. So this one has a slope of 2. And by the way, the letter that goes with slope is M. Why M? I don't know. It just is. Okay, and these two, I think we'll have enough room to do this on the same one. So this one, you see how it's going in a downward direction from left to right? That is considered a negative slope. So whatever I find as my slope it should be a negative number. And then this one is a positive slope, just like the one we did before. And like the one we did before, they have dots already marked for us to use. Now, on this one, now you should go up and then over, because rise, over, run. So it just depends on whether you're going to the right or to the left. So I'm going to count how many times I'm going up. That's 1, 2, 3, 4, 5. Remember, that's negative. And then now I'm going to the left. So 1, 2, 3, 4. So the way you could look at this is you could say that this is up 5, which is positive, and then to the left 4, which is negative 4. It doesn't matter because that it's negative 5/4 regardless. Whether you put the negative with the 5 or out to the side, or you put it with the 4. So the slope of this line is negative 5/4. And yes, it can be improper. Usually it's a ratio because they're wanting to compare the change in y to the change in x. And you'll see more about what that means later. So this one you have 2 points. So I'm going to go rise over run. So 1, 2, 3, 4, 5, 6, 7. I know it's going to be, you don't have to always put the positive there. I'm just showing you. And then going to the right, 1, 2, 3, 4, 5. So that would be 7/5. So the slope here is 7/5, or positive 7/5. Remember, that's m. Slope is the variable m. Okay, here's another negative. So let's suppose that you don't particularly care for the 2 dots that they chose for you to use for rise over run. You can use any 2 points as long as they are on the same line. Now, I'm not going to want to use anything that's going to be harder for me in the long run. I don't want to choose right there because that's going to be dealing with fractions or decimals. This one's not exactly on a point. This one isn't either. So it needs to be like in the middle of where it crosses at a corner. So that's why the only one that will work on this one is the one that they chose, or the 2 that they chose. So this is a negative slope, just so you can remember that. Put a negative there. And let's go rise over run. 1, 2, 3, 4, 5, 6, 7. So that's up 7. And then to the left, 1, 2, 3, 4. So it's still going to be negative 7/4. Seems weird, doesn't it? Now, if this could be reduced, you would reduce it, but you can't reduce that. Okay, now look at these 2 lines. These are not very steep. So the steeper the line, the larger the slope number is going to be. Or so like the first one we did, the slope was 2. So I would assume that was a pretty big, that's a steep line. Now the closer you are to 0, the less steep it is, or the flatter it is. So let's look at this negative slope here. The 2 dots are here for us. Let's go rise 1, 2, and then 1, 2, 3, 4. So 2 over negative 4, which is negative 1/2. So the slope here is negative 1/2, which makes sense because a flat line is a slope of 0. So 1/2, whether it's positive or negative, is pretty flat. Let's look at this positive slope over here. So you go up 1, and then to the right, 1, 2, 3, 4, 5, 6. So that's The rise is 1 and the run is 6. So the slope of that line is 1/6. So that's a pretty flat line with a little bit of a slope to it, a little bit of steepness. Okay, so it's just rise over run. You're just counting and put them in fractions. Okay, so this one is a straight line, and you should automatically know that straight lines, flat straight lines, have a slope of 0. But here's how you could look at it on a graph. And this is weird because I don't normally look at it this way. But let's just pick 2 points on the graph. So how far are you going up to get to this second point? Well, you're going up 0 points, right? And then I'm going to the right how many times? So my run is 2. Well, 0 divided by 2 is 0. So that's why it's a slope of 0. Now, this next one's going to be a little tricky for you to understand, but we'll do plenty of examples. Okay, so first of all, pet peeve of mine is drawing lines and not putting arrows on them. So let's just suppose I chose these 2 points. So this is a straight vertical line, and it's going to have a weird slope to it, or a weird answer. But if I'm going from this point to this point, my rise is 2. Now, what is my run? Am I going anywhere left or right? That would be 0. Well, you can't divide by 0. You cannot divide by 0. It's undefined. Okay, and I'll tell you why in a second. Undefined. Now, you don't even have to do anything to this one or the one before it, because it's a slope of 0 and this is undefined. Now, let's look at this. Let's look at this way. If you have a 0 in the numerator and you're dividing, so you're saying what number times 2 gives you 0? Well, what number times 2 gives you 0? Well, 0. So that's why the answer to this one is 0. But the other way around, you're asking what number times 0 gives you 2? It doesn't exist. Anything times 0 is 0 because of the 0 product property. So that's undefined. Now, sometimes, and in your assignment, unfortunately, instead of saying that the slope is undefined, some people will say that there is no slope, which is true. There's no slope here, but there's no slope on a straight line either. So I don't like this because students confuse that as being a slope of 0. But whenever I see that happening, whenever I see them using no slope, using the words no slope instead of undefined, I'll let you know that in place of no slope, I want you to use the word undefined, because that's really what it is. Okay, so I'll show you on a screencast. We'll do part of your assignment with you, and then you'll have some to do on your own. Peace out.